This week on the show, we covered a 5 times if bridge performance improvement that Christoph Provost has been making. How Unix has won is an article we also read a little bit through. We have an article about understanding the VLAN configuration on FreeBSD. We cover Beehive PCI passthrough on OmniOS, as well as the TrueNAS 11.3 U2 update and more in this week's episode of BSD Now. BSD Now, episode 350, Speedy Bridges. Recorded on the 13th of May 2020. Hello, I'm your host, Benedict Täuschling.
And I'm Alan Jude.
Welcome back to BSD Now, your show for everything BSD related. And we just jump right into the headlines as always, or most of the time, because we have interesting things. There is a 5 times if bridge performance improvement coming down the line.
Yep. So with the FreeBSD Foundation grant, Christoph Provost has harnessed the new parallel techniques to uncork the performance bottleneck in the bridge driver. So as an independent embedded systems developer, Christoph certainly knows his way around the network stack. For the past several years, ever since George Neville-Neal approached him at AsiaBSDCon with an offer he couldn't refuse, he's been the maintainer of FreeBSD's port of PF, the OpenBSD packet filter. Even before this, if you've used IPv6, you've benefited from Christoph's work on cleaning up fragmentation handling in the firewalls, and a bunch of other things. He also did a bunch of work on PF Sync, the tool that lets you sync the firewall state between your active-passive firewall pair so that when you fail over, all of the open connections don't get disconnected. Like all your NAT state and so on is kept in sync between the two. And he did a bunch of work to improve that. And as part of that, they also found that there were performance problems with the bridge driver, the tool that effectively turns a FreeBSD machine into a switch. And it's heavily used especially if you're using vimage jails on FreeBSD or if you're using Beehive. It's most common to take either the e-pair from a VNet jail or the tap device you get from Beehive or OpenVPN or WireGuard or anything like that, and then use the bridge driver to connect that to your real Ethernet so that they can all be on the same network. So the FreeBSD Foundation agreed to fund Christoph to work on ifbridge and make it better. So Christoph provided a detailed technical review of his work in the May and June issue of the FreeBSD Journal. For our purposes here, suffice to say that the current ifbridge implementation contends heavily on a single lock called the bridge lock, which is a mutex or mutually exclusive lock. It's a way to ensure data integrity by only allowing one core of your machine to access the data at a time. Unfortunately, the ifbridge implementation stops cores from doing the things a switch should do, like forwarding packets, when any core is writing to the bridge. This limits throughput to about 3.7 million packets per second, regardless of how many cores your system has. After iterating through some options, Christoph's ultimate solution takes advantage of the new Epoch framework that was added in FreeBSD 13 through clever use of concurrency and the tools added to FreeBSD called Concurrency Kit. Epoch allows the safe use of protected data structures without acquiring a lock, either a mutex or a read-or-write lock. So it doesn't have to be locked at all. As Christoph explains in the article, the final result is that we can still only perform one modification of the bridge state, i.e. adding an interface or learning which interface a specific MAC address belongs to at a time, but we can keep processing packets on the other CPUs while we're doing this. The way Epoch works is it's almost like a copy on write type thing. Like the other cores can see the old version of the data and keep using it until the new version exists. And then we can guarantee we don't free the old version until everybody's finished using it. It's basically a safe way to do kind of this slightly asynchronous update. Anyway, because we can now continue to process packets on the other CPUs while one CPU is modifying the bridge instead of, as soon as anybody's modifying the bridge, everybody else has to stop working. This new ifbridge implementation can forward 18.6 million packets per second on the test machine for a more than 5x improvement in throughput. Mm-hmm. I need to update my home NAS to have this and see if my VMs can now go a lot faster than they could before.
Oh yeah. So that's great improvement, definitely, by using this epoch framework.
Also, Christoph live streamed some of his work on this, and the videos of that over on his Twitch profile, which I've linked in the show notes. So if you want to get Christoph's beer recommendations and also watch him explain a little bit of how this works and how he developed it, he streamed a couple of times now, I think, and the videos are up there in the archive, and you should check them out.
Yeah, and so this was done with the FreeBSD Foundation grant, and the money, I think, is well spent in this case. So thank you, Christoph, for this. And I guess there was more work coming down the line. He's not finished yet, but the improvements yet are already very exciting. Then next we have How Unix Won in a blog post by Vivek Haldar. How Unix won. Unix has won in every conceivable way. And in true mythic style, it contains the seeds of its own eclipse. This is my subjective historical narrative of how that happened. I'm using the name Unix to include the entire family of operating systems descended from it that have been heavily influenced by it, which includes Linux, SunOS, Solaris, BSD, macOS 10, and many, many others. Both major mobile operating systems, Android and iOS, have Unix roots. The billions of users dwarf those clunky things like laptops and desktops, but even there, Windows is only the non-Unix viable operating system. Almost everything running server-side in giant data centers is Linux. How did Unix win? So the bullet point first is it was built by programmers for programmers. If you read the early papers describing Unix, there's a separate link to those, you will see how the key abstractions, the hierarchical file systems, for example, permissions, processes, interactive shells, pipes, have lasted conceptually unsullied for decades. That could only have happened if it exerted such a force field over geek minds that they propagated it. Then there's the majority of it written not in assembly language, but in C, a higher level language, hence making it portable. This enables relatively easy ports to a wide variety of hardware.
A wide variety.
Wide, very wide. A freak historical accident as well. AT&T Labs, where it was developed, was forbidden under its antitrust settlement from commercializing products unrelated to its core telecom business. Hence, Unix was licensed very cheaply to universities, including University of California at Berkeley, which subsequently built one of the most influential branches in the Unix family tree, BSD. Apparently, AT&T classified Unix as industrial waste for tax purposes when licensing it. Okay.
Okay, that story I want to know more about. There's a link there that I'm going to open and read later.
That is kind of a, yeah. And so Unix spread through academia, and those students spread it through corporations after they graduated. See, that's how it's done. It's a strategy that has been used by every major tech company, only in this case it was organic. So there's a bit more historical parts, and then how and why would we move past Unix? Unix, which got standardized into a POSIX spec, has accreted a tremendous amount of complexity over the decades. The POSIX spec is 3,000 pages long. Unix now has nearly 400 system calls, or for Linux. What started as a clean, pure, minimal, and elegant set of system abstractions has become a complex beast. And there's a bit more about the ecosystem in various operating systems. The entire ecosystem in which an operating system exists is changing. Application level experiences are hermetic and make the underlying operating systems more or less irrelevant. Just look at Android or iOS or Chrome OS. Programming to a virtual machine, like the Java virtual machine, makes programmers much more invested in their PL than the operating system itself. In the above points, as a closing point, they raise an interesting question. What does a modern operating system want? Look, for example, at Fuchsia, which is going in the direction...
Fuchsia.
Oh, that's how
yeah, fuchsia is in the color.
I learned that now. Okay, which is going in the direction of a microkernel with capabilities that pushes most drivers and operating system services out to user space. These are ideas that have been floating in academic operating system research for decades, but could never gain real mainstream acceptance because of the high barrier to making a viable real-world operating system. This is the effect Rob Pike was talking about in his Systems Research is Irrelevant talk, separate link here, but the prior two trends are finally dislodging the iron grip of Unix, and operating systems are becoming interesting again.
The point about the kind of how operating systems are kind of being hidden behind the hermetically sealed application layer really plays out in how almost everything is either in your web browser or it's an Electron app, which is just an embedded a browser that runs one thing. Basically using the browser as the operating system, and the browser then talks to your real operating system. I guess actually, so things like, what did I just say it was called? Electron. Electron is basically the new Java. It's the virtual runtime that you can write your application to, and then the browser takes care of running on the different operating systems.
Time for the news round. We have the second part of the central log server tutorial we teased on last week's episode. So this is the second part here.
Yeah, so this blog post continues where the last one left off. Open source solutions to check your syslog log messages exist, such as log check or log watch. Although these are not too difficult to implement and maintain, I still found these to be too much at times. So I went for my own homegrown solution of checking the syslog messages on my central log host. And the solution presented in this blog works fairly well for him, but your results may vary. Some events that they've detect here are failed hard drives, daemon which are not configured correctly, which are behaving differently than expected, or disks or volumes that are filling up, or bad requests to web servers and mail servers. So again, if you have an up-to-date FreeBSD 11 or 12 machine and you've already set up your central log host to aggregate the logs from a bunch of machines, then you're good to go. You also need a mail client set up so that you'll be able to send mail. So in this case, they install bash and logcheck, and it looks like they also have another tool called logtail2. So the logcheck shell script, which they have here called check-syslog.sh, sets a bunch of environment variables and controls how the logs get checked. And then, for example, they have a function called failures, which greps for any of these words that are considered failure, like error, crit, invalid, fail, false, restart, deny, disable, ignored, broken, exceeded, blocked, offline, etc., or exceptions and others like that. And they also check that the script's running as root and a bunch of other bits. And they schedule this to run every hour on the hour and check it and make sure it's good.
Okay. Yeah, that's nice. As a completion of the whole tutorial, if you put part 1 and 2 together.
Then yeah, especially useful if you have a lot of machines and you want to watch for certain log entries on all of them.
Yep. Next up, we have the understanding VLAN configuration on FreeBSD. It starts with, until recently, I've never had a chance to use VLANs on FreeBSD hosts, though I sometimes configure them on Ethernet switches. But when I was playing with VNet jails, I suddenly got interested in VLAN configuration on FreeBSD and experimented with it for some time. I wrote this short article to summarize my current understanding of how to configure those on FreeBSD. So, terminology, for those who don't know what a VLAN is. So he thinks the word VLAN is being used in two different senses. In a narrow sense, it stands for IEEE 802.q VLAN tagging. On FreeBSD, it's implemented as VLAN, so there's a man page for it, of course. Logical interface sub-interfaces. In a broader sense, the word VLAN is used to describe a layer 2 network, which is physically or logically created in a wider network. On a single Ethernet switch, a VLAN can be regarded as a virtual switch with a selected subset of its Ethernet port. On FreeBSD, it can be represented by bridge. And this is the bridge that just got much faster. Okay, so in this article, I use the word in the latter sense. Though the words VLAN and bridge are interchangeable, in most cases, they are not for really network, for the network geeks, be careful. For the VLAN in the narrow sense, I use tagged or trunk ports or interfaces. Describes the target topology along with a picture to see where VLANs go and which bridges there are. I set a goal to create the following network topology with an Ethernet switch, a FreeBSD host, and VNet jails on them. The switch has the layer 3 capability and acts as a router for this network. Later I will also try to have the host forward IP traffic between the VLANs. As I'm not a network engineer, nor any engineer of any kind, there might be something which makes no sense in real networks, but anyway, I'm going for it.
Yeah, so basically it looks like he has 3 sets of jails, and he wants to, basically he has bridge 10, 20, and 30, which correspond to VLANs 10, 20, and 30. And those all route out via VLAN 1, which is his regular EM0 NIC out to his switch.
Oh yeah, and I like how he structures this. So he makes a configuration change and shows how this is done, and then gives us an updated network diagram to see, what kind of VLANs are now existing, what kind of bridges are configured at this point. So there's a new picture each time there's a configuration change being done.
Yeah, and you can see what each change adds to the diagram. Yeah, it's very helpful.
Then there's a section with additional topics, how to allow the host to access the jails directly, if that's your desired configuration.
Basically, putting an IP on the bridge interface on the host for each of those subnets, so that the host is also in that VLAN, basically. Yeah, and then he configures forwarding and sets up some rules for that.
Oh yeah, so if you follow this along, you should not have a problem to recreate the same kind of setup.
Yeah, I like the way they did the diagrams, like you said.
That's pretty cool. Okay, and then once we're on the Beehive topic already a little bit, we also have an article about using Beehive PCI passthrough on OmniOS.
Yeah, so they say some hardware is not supported in Lumos yet, but luckily there's Beehive, which supports PCI pass-through to any modern guest operating system. To continue with my OmniOS desktop on modern hardware, I would love Wi-Fi support. So why not use a Beehive guest as a router zone, which provides the required drivers? I think I've seen people do this even on FreeBSD, where they end up bridging into the past the Wi-Fi into the guest and set up their routing so they actually go into the VM to get on the Wi-Fi to get out to the internet. Which, it works, I guess. So first of all, it requires an up-to-date OmniOS version, which provides Beehive and pass-through support. So you want to make sure you have that, and you have the Beehive package and Beehive brand of zone. So they have kind of an example here. You can see the global zone, which is the host basically, is passing the PCI Wi-Fi device through into the Beehive zone, which is the guest, and it's also setting up a VirtIO net VNIC into the host. So then the host will actually basically use the Beehive guest as its router, and that Beehive guest will then NAT that connection out over the Wi-Fi. And so they show how to do that. Basically create a bridge interface, which is actually called switch 0 on Illumos, and then create virtual NICs, one for the uplink and one for Beehive. Set those up, adding an address to the uplink one so that you have an address and you're in the right subnet, and then setting up pass-through of the Wi-Fi into Beehive by basically in your etc ppt aliases, you say pass-through, PCIe device 0x86, 85, and that will pass through the Wi-Fi. Again, they used prtconf, which is like PCI-conf, to get the ID of the Wi-Fi. Once that's all set up and running, see that the device is now passed through to the Beehive instead of being attached on the host. Then they create a ZVol for the Beehive to run off of, download, in this case, FreeBSD. So they're downloading FreeBSD to get Wi-Fi drivers.
Okay.
So they create the zone with FreeBSD in it, get it up and running, and add that pass-through device into that Beehive. So now they'll have a Beehive running with FreeBSD in it, and they'll pass through the Wi-Fi into it. And then they configure that FreeBSD machine to be the NAT router for their Wi-Fi. So it actually includes, at the end there, the setup of loading the Wi-Fi driver in FreeBSD and configuring PF to be your firewall and do the NAT for you. And so, this is how to use FreeBSD to run your Wi-Fi on your Illumos machine.
Yeah, if it works, and it's definitely an interesting use case. Yeah. All right, and then we have updates. TrueNAS 11.3 U2 is generally available.
Yep. So remember, FreeNAS is now called TrueNAS Core. They've unified the code base with the commercial product. The new release is now available.
So this update is based on FreeNAS 11.3.
Oh, in the TrueNAS version, they have the nice graphical overview of what your hardware looks like.
Oh yes, yeah, that's good. The more disks you have, the easier it would get to lose sight of which one is in which pool.
Which one is where?
But they got some listing of major improvements. So they have ZFS replication, 8 times performance improvement. Wow, 5 terabyte per hour, parallel tasks, auto resume. Simplified setup with wizards for iSCSI, SMB pools, networking, and replication. They also have SMB improvements with user quotas via Active Directory, shadow copies, and ACL managers. Easier plugins, the UI redesign, categories, NAT reduces IP addresses. Dashboard and reporting got faster response times and more relevant data. Configuration management got API enabled config saves and audits. and graphical enclosure and high availability management. Yeah, that's what we have in this screenshot.
Yes, and there was also the improvements to integration with Microsoft Active Directory, especially now that the defaults for the security things are changing in Microsoft. They have all the updated compatibility stuff in TrueNAS now.
Oh yeah, I think people will be very happy to update their systems with this.
Yep.
All right, time for Beastie Bits this week. We have a couple of articles, but if you think this is a section where your article is still missing, then send your article to feedback@bsdnow.tv and it will appear in a future episode. Here we have HardenedBSD's April 2020 status report. Sean Webb writes, Hey HardenedBSD community, it has been a while since I've written a status report and now is definitely time to do so. Over the past few months, I've put my focus on infrastructure stability and merge conflict resolution. The work on exploit mitigations is still somewhat on pause, though I've made slight progress on cross-DSO CFI. Our build infrastructure has been hosted at my current employer for a few years now. I'm so grateful for G2 Inc., now Huntington Ingalls Industries, for their support and help in ensuring the continued success of the project. After over 5 years of service at my current employer, I've tendered my letter of resignation. The people I've met, the projects I've worked on, and the culture and virtues instilled in me made me fall in love with G2. I've decided to take a new employment opportunity. Blackhawk Nest will host a HardenedBSD build infrastructure with room to grow. I've architected the infrastructure such that the migration should be mostly plug and play, only needing to change a few IP addresses. I plan to shut down the infrastructure in preparation for the migration on 2nd of May, so that's already done by the time you listen to this episode, which is 1 week in advance of my start date. Builds will resume once the infrastructure has been deployed at the new facility. Note that published builds and package repos will still be accessible. Only the build infrastructure, which is separate from the infrastructure serving the builds and package repos, will be down. I do not currently have a date for when the infrastructure will be back online, but I suspect around 2 to 3 weeks from 2nd of May. I'm excited for this new opportunity and especially for Blackhawk Nest for agreeing to host the build infrastructure. I'm positive that the relationship between HardenedBSD and Blackhawk Nest will be symbiotic. Thank you so much for your help and support of the project.
Yeah, well, I guess with the clarification that packages and stuff will still work, I guess it's really not that big of a deal.
Yep, good luck to HardenedBSD's in its new home, in the new nest, I would say. And yeah, we'll give you updates if there's something new happening in that space. Oh, since a lot of people are currently looking for a job, mostly not on their fault, we have the NYC Bugs mailing list, the listing of open source development jobs from US nationwide consulting company. Oh, there's a bunch of things. Okay.
Yep. So they have a bunch of job posts available, including intelligence analyst, Drupal developer, Java developer, PHP developer, Scrum Master, NetApp storage management consultant, application analyst, backend services developer, user experience expert, compliance analyst, IAM architect, and service delivery coordinator.
And they're all in different states, so not all in one place. So that's good if people don't want to move.
Yes. So there might be something near you if you're looking for something.
Yep. Hope you find a job this way. And yeah, let us know if you got an interesting job in the BSD space, for example. All right, it's feedback and questions time, and this will be a very sad and a boring section if you don't continue submit us questions or feedback to this part of the show. BSD, yeah, BSD questions, of course, are our preferred thing, but you could also ask us ZFS and all the other things around computers. We try to answer those, and if not, then we'll open it up to the wider community. So send your question to feedback@bsdnow.tv, and then you will appear with your question in a future episode. Greg did this and has a Lenovo question, and we'll start with him. So Greg writes, Alan, Benedict, and JT, my impression is that a lot of BSD users have Lenovo laptops. That might be true. Lenovo rated it critical issue since it seems to fix an issue that could brick your Thunderbolt port after 6 to 12 months of normal use. It seems to affect the to most recent Lenovo laptops from the 2017 to 2019 era. The problem was linked to a bad firmware update last year, which appears to wear out the Thunderbolt controller's SPI ROM that holds configuration. And here's the link to Lenovo's website to get the fix.
Mhm.
Yeah, that's good to know.
Yeah, slightly confusingly, I think when we talked about this a while back as well, my laptop is not on the list, my X270, but other laptops of the same generation, like the T470 and T570, are. Even the ThinkPad 25th Anniversary Edition is. I don't think mine actually has Thunderbolt. It does have USB-C, and they list USB-C or Thunderbolt connectors might be the problem. So yeah, I'm not sure if my laptop is actually at risk for this or not.
Yeah, you should probably check for the firmware update page if there's something new in there and just apply it. See if things will not break after 6 to 12 months.
Yep. So yeah, if you have a modern Lenovo, you probably want to double check this list, link in the show notes, and make sure your laptop's not going to suddenly brick itself because it keeps overwriting its SPI flash.
Yeah, which is kind of not what you want to have. And the firmware updates typically bring a lot of other improvements and security fixes as well. So staying up to date on this space is always a good idea. Okay, so thanks, Craig, for this. And next up is Matt with a question or feedback about BSD packaging. Matt writes, "Hi all. On last week's show, you requested positive reasons to switch to BSD, so I thought I'd write in with one positive data point about the BSD community. Okay, let's hear it. I wrote an application I thought would be of use to others beyond myself, so I started to think about distro packaging. Ubuntu seems to have the largest mindshare these days, so I started the process of packaging it for Debian. If you've never tried to package something for Debian before, it's a little bit like being repeatedly told your princess is in another castle. While I was still in the midst of this, a stranger filed a curious bug report against my project in which they indicated their platform was FreeBSD. In investigating this, I realized they were in the process of packaging my application for FreeBSD. My application ended up being packaged and shipped in FreeBSD by this helpful stranger before I was even halfway through the Debian process. For me, this interaction really showcased the generosity and friendliness of the BSD community."
Yeah, I'm glad Matt had such a good experience.
Oh yes, yeah, it's definitely the people that make this packaging and ports framework awesome. You always think about, oh, these so many thousands of ports that are available. You just do package install or make install, but there's a lot of things that people do behind the scenes to make that so easy for you as the end user.
Yeah, but also looking at this from the perspective of the person who wrote in here, main reason people develop open source software is for people to use it. And finding out that people are using it and that it's working for them is most of the reward you get from doing open source software. Is that good feeling, though other people are using this and it's helping them. I've made other people's lives better. And, this just, so it's important to make sure that we do that and give back to the people that have developed the tools that we find so useful.
Oh yeah, you want to focus as a developer on fixing bugs, developing features and stuff, and not just creating the package to bring it out there and give.
Right, but also the people doing the packaging get some of the credit for, that application being able to just package install away rather than you having to do a bunch of work to get the application working. And there's a whole slew of people involved in each step of this, and they're all important. If any one of those breaks down, then something doesn't work.
Yeah. And it's a great way here for people to get started in an open source project. Like maintain a couple of ports here and there, and then you never know how deep you end up. Oh, and I might as well make changes to the docs, or add another port to my repertoire. And so your list of things grows over the time, depending on how much time you want to spend on it or how much time you can put into that. And you never know what kind of people you meet, what kind of interesting projects you're working on. And so this is a very easy gateway to get more experience. Okay, so thanks for that. And
I guess just a reminder before we get into the last one, the FreeBSD core team election is coming up. So if you're a FreeBSD developer of any kind, even ports and docs, and all that counts, the process to run for the election opens up in just over a week from when this episode comes out. So start thinking about that.
yeah, whether you want to run for core or just want to vote, definitely check out the platform that we put up there. There should be an email already in your inbox about this. And then we'll have.
Yes, on the developers list, and make sure that you can log in and everything before it starts, so that I don't have a slew of people having trouble when the election is actually happening.
This is one of the unique features in the FreeBSD space, that we have elections every 2 years, and that you can change or make change yourself if you want. And so the core team is an important part of the project, so that people need to run for that. All right, so let's go to Morgan, who's the last one in this week, with a performance question. Morgan writes, I'm looking for a basic CPU/memory performance measurement tool so I can check the relative speed of my FreeBSD systems. I run several on DigitalOcean and my own hardware, even a Beehive instance. I like taking speed measurements before and after operating system and hardware upgrades to track variations in performance. For my purposes, the score doesn't need to be super scientific benchmark, just something that gives me a basic idea of a machine's speed. In the past, I turned to the old ubench tool for this. It runs for a few minutes and then outputs a single score for CPU and memory. It's great for this, but it takes a while and tends to crash, especially in Beehive. Is there a simple alternative that is quick, convenient, and runs from a command line? No X windows. There's more. What I have used in the past to tell if my DigitalOcean droplet was on an overloaded machine, then I delete it and get a new one, was just the SHA512 benchmark. Now that
Yeah, so that's a built-in benchmark in FreeBSD. If you run SHA-256 or SHA-512-T, it runs a little benchmark and outputs a speed.
Yeah, and he mentions that it can be impacted by special hardware, having special codes to make that SHA-512 faster. But there's a variant truncated to 256 that uses that ZFS is using that has never been implemented in hardware. So it's SHA-512T256- It will run for something like 2 to 5 seconds and also outputs a speed that you can compare between machines. It is quite basic, but should give you a reasonable comparison. Note it only uses one CPU, so it will score mostly based on gigahertz of one core.
Yeah, it's interesting to see somebody using the truncated version, because I added that to FreeBSD because ZFS needed it. Because in ZFS, the space you have to write the checksum on disk is only 256 bits, but SHA-512 is actually about 50% faster to calculate than a SHA-256. So switching ZFS to use SHA-512 but just truncated to 256 bits is faster than doing the SHA-256 on 64-bit machines. But for one reason or another, when they standardized the truncated version, they use a different initial seed than you do for regular SHA-512. And so, yeah, most of the stuff that accelerates SHA-512 doesn't apply to the SHA-512 truncated version. And so it can be a useful way to compare that, yeah.
A good memory benchmark? Beehive? Beehive.
I don't know. I'm not sure if there's ever anything that could be called a good benchmark, but
Yeah.
especially in a VM, because there's just so many side effects.
Or Poudriere, but you wouldn't run Poudriere everywhere. He's definitely not mentioning I/O, so it's CPU and memory performance he's after.
Yeah. Well, in this case, it's mostly, do I have the noisy neighbor problem, which is this concept on, all clouds like Amazon or DigitalOcean or whatever, where if they're other people's VMs that are on the same machine as you are hogging all the resources, then your machine will be slightly slower or just won't be able to burst as much. And so, yeah, when you first get a VM, if you run this test and see that, I have 3 identical VMs, and they're all possibly on different hosts, and one of them is significantly slower than the other, it's like, well, then I will delete that one and get a new one before I go setting it all up. Or just do something to cause it to migrate to a different host.
Yeah, bad neighborhood here. Bad different cloud here. Yeah, so if anyone else from our listeners who has a benchmark that they always use for this, let us know, and then we'll add this either to next week's show notes or just put a follow-up in here so that people can find it and use it more. Or if someone has developed such a test, then definitely give us a point to your project website, and we'll be happy to mention it. All right, I think that pretty much covers this week's episode. Thank you for listening in, as always, and you hear us definitely next week again.
Yep. Make sure your RSS feed is using the URL of bsdnow.tv, and to send your feedback to feedback@bsdnow.tv, and we'll see you next time.